Hello there guys, so I'm already in my art studio and today I'll be showing you how to perform a linear regression and interpret the output in R. So to begin, I shall just load in my built-in dataset. That dataset is called empty cars. It's a dataset about cars. Just run my data. I shall just call it df. After doing that, I shall check the head of the dataset just to get a snippet of how the dataset looks like. You can see the dataset here. It contains some variables mpg, cyl, disp, and other variables. So I just want to remain with the first three variables so that I can show you how to perform the linear regression. So I shall just select the columns to use. If I run this one, now our df contains the first three columns. Then let us just attach the data frame. So after attaching our data frame, let us fit our linear regression model. So guys, if you want to fit a linear regression model in R, just type in lm, then this is the dependent variable, and these ones are the independent variables, or this one is the response variable, and these are the predictor variables. So let us now get the summary of the model that we have just created. If you come and check at the summary here, if you look at the output, you find that the first output is call. This call function just gives us the function, the formula of the model, or the function of the model. This is the function that we written here. Here you can see just the same. And then the residuals. So guys, what are residuals? Residuals are actually the actual values minus the predicted values. That's what residuals are. So guys, if you check here, find the minimum residual, the first quartile, and the median. So guys, you want your residual to have a median that is closer to zero. If it's closer to zero, it shows that our residuals are symmetrical. But if the median is far away from zero, it means that our residuals are skewed. So that's not good. So now after the residuals we have the coefficients. So here the coefficients, if you remember, the equation of linear regression is always y is equals to mx plus b. So our b is always the y-intercept. So here is the estimate of the y-intercept. So this one is the intercept. This is the value for b, and this one is the coefficients for the independent variables, and this one is the standard error for the coefficients. Just the standard error is like the standard deviation of the coefficients. This one's here. The t value, just the t statistic. I hope you know what t statistic. And the pr is the p value, the p value for this our coefficients. So guys, if your p value is less than some certain significant level, that's when our intercept is significant, or our coefficients are significant. So like here, the cy coefficient is significant. This one is not significant because it is more than 0.05. So if you continue going, you see here there's a residual standard error. So guys, the residual standard error is the distance of our observed values, the distance of observed values to the line of best fit. So guys, you want the distance to be very minimal. So here our distance is 3.005 on 29 degrees of freedom. So then you have multiple r squared. So this one is how much variation is explained by the independent variables. How much variation on the response variable is explained by the independent variable. Like here we have a very good multiple r squared, like 75%. This means that 75% of the variations of the response variables are explained by the independent variables. Then you have this f statistics. So this f statistics determines how well our model fits in the data, and we also have a p-value. So p-value is similar to f statistic. So guys, you always want a p-value to be less than your certain significant level, so that to show that the model fits in the data very well. So if you have a p-value, this one is very small, so this one here, it fits the data very well. So that is it guys. Please subscribe to my channel.